Here are 14 practice problems on trigonometry or SOHCAHTOA. As per usual, I'll link these questions and the answer key in the description, so if you want to work ahead, you can go ahead and do so. But if you need a little bit more help, I will be going through every single question. Or if you need further clarification, feel free to ask me. Anyways, let's get started with question number 1. Triangle FGH is similar to triangle JKL, where angle F corresponds to angle J, and angles G and K are right angles. Alright, so I went ahead and drew the two triangles. We know that angle G and K are 90-degree angles, and since angle F corresponds to angle J, that means they have the same measure. If sine of F is equal to 308 over 317, remember in SOHCAHTOA, sine is going to be so, which is opposite over hypotenuse. So let's look at angle F. The opposite is going to be this side right here, and that's 308. And then the hypotenuse is this side right here, across from the 90-degree angle, and that's going to be 317. What is the value of sine of J? Now, we know that since angle F corresponds to angle J, they have the exact same measure. So sine of F would be the exact same as sine of J, which means that our answer would be 308 over 317, or B. Question number 2. In right triangle RST, the sum of the measures of angle R and angle S is 90 degrees. Alright, so I went ahead and drew the right triangle. The value of sine of R is square root of 15 over 4. So sine in SOHCAHTOA is going to be so, which is opposite over hypotenuse. So here's angle R, and opposite of angle R is going to be this side right here, and that's going to be square root 15. And then the hypotenuse is going to be this side right here, opposite of the right angle, and that's going to be 4. What is the value of cosine of S? So in SOHCAHTOA, cosine is going to be K, which is adjacent over hypotenuse. So here's angle S, and the side adjacent to angle S is this side right here, which is square root of 15. And then the hypotenuse is of course across from the right angle, which is this side right here, so that's going to be 4. That means our answer is square root 15 over 4, or B. So I think you could tell here, but whenever you have two angles that add up to 90 degrees, the sine of one angle is going to be equal to the cosine of the other. So here, since angles R and S add up to 90 degrees, that means that the sine of R is equal to the cosine of S, and then the cosine of R would be equal to the sine of S. Question number 3. In the figure above, what is the value of tan of A? So tan in SOHCAHTOA is going to be TOA, which is opposite over adjacent. So here's angle A. The side opposite of angle A is this side right here, which is 20. And then the side adjacent to angle A is right here, and that's going to be 21. So our answer is 20 over 21, or C. Question number 4. Triangle ABC above is a right triangle, and sine of B is equal to 5 over 13. So in SOHCAHTOA, sine is going to be so, which is opposite over hypotenuse. So here's angle B, and opposite of B is going to be 5. And then the hypotenuse is going to be opposite of the right angle, and that's going to be 13. However, you'll notice here that the actual length of the hypotenuse is 26 and not 13. But I think you can tell what they did. All they did was multiply this ratio by 2 to get 10 over 26. So that means that this side down here, the side opposite of angle B, would actually be 10. What is the length of side BC? So we're trying to find the length of this side right here. So here, we're trying to find a missing side length in a right triangle, so I think it's obvious what we do. We're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So a squared is going to be 10 squared plus b squared, which is what we're trying to find, is equal to c squared, which is always the hypotenuse. And now you can solve for b. I'm gonna just put it in desmos. Instead of an equal sign, you want to put a tilde. And you get that b is equal to 24. So the length of side BC is 24. Question number 5. In the triangle shown, what is the value of sine of x degrees? So in SOHCAHTOA, sine is so, which is opposite over hypotenuse. So here's angle x, and opposite of angle x is 16. And then the hypotenuse is going to be opposite of the right angle, and that's going to be 23. So our answer is literally just 16 over 23. This is a hard difficulty question, by the way. Now, if they wanted you to actually find the angle measure and not just the ratio, they would probably ask you for like, what's the value of x degrees? But since they asked for sine of x degrees, we're trying to find the ratio. Question number 6. In the figure above, tan of b is equal to 3 over 4. So, in SOHCAHTOA, tan is TOA, which is opposite over adjacent. Here's angle B, and you notice that angle B is actually shared by two triangles. It's in this big triangle right here, and it's also in this smaller triangle. So let me quickly separate them so you can tell them apart a little easier. Alright, so I went ahead and separated the two triangles. So here are our angle B's. Opposite of angle B is going to be 3. And then adjacent to angle B, which is this side right here, is going to be 4. Now you should notice that both of these triangles are 3, 4, 5 triangles. So that means that the hypotenuse will be 5. Now if you didn't know this, you could of course always just put it in desmos. And instead of an equal sign, you want to put a tilde. And you get that the final side would be equal to 5. Okay, let's continue reading. If BC is equal to 15, so this side right here is equal to 15. So you notice that we calculated it to be 5, but in reality it's 15. So this is just like the question we had a few questions ago, where all they did was multiply the ratio by a certain number. So I think you can tell here, but to go from 5 to 15, they multiplied by 3. So that means that they multiplied this ratio by 3, so it'd really be 9 over 12. So in reality, that means that these two sides, instead of 3, it would turn into 9 when you multiply it by 3. And instead of 4, when you multiply it by 3, it would be 12. Alright, so you should notice by now that whenever you get these ratios, that doesn't mean the side lengths will always be those numbers. It doesn't mean the side lengths will always be 3 and 4. Because in this case, it could be 9 and 12. And all they did was scale it up. Now they could have scaled it up by a factor of 5. And then it would end up being something like 15 over 20. But the ratio would still be equal to 3 over 4 because it would end up reducing. Alright, let's keep reading. DA is equal to 4. So that's actually not in either of these two triangles, so let's look at the original figure. It's gonna be this line right here, and we know it's equal to 4. What is the length of DE? So we're trying to find the length of this side right here, or this side. Alright, so we know that 3 is obviously not going to be the actual length of line DE, but the length of line DE will be 3 times a certain number. Now all we have to do is find out what that number is. In the big triangle, that number was 3, but we don't know if that's going to be the same in the smaller triangle. Well, I mean, obviously it's not going to be the same because the smaller triangle is smaller. Alright, so the first step is going to be finding out the actual side length of this side right here, side BD. So we know that the entire side length of side BA, or in our original triangle, this side right here, is equal to 12. And to find the side length of side BD right here, we would just do 12 minus 4. So we get that side BD is equal to 8. So down here, side BD is equal to 8. And to go from 4 to 8, they multiplied by 2. So to find the actual side length of side DE, we're going to multiply by 2. And we get that our answer would be 6. Question number 7. The side lengths of right triangle RST are given. RS is equal to 440, ST is equal to 384, and TR is equal to 584. Triangle RST is similar to triangle UVW, where S corresponds to V and T corresponds to W. Alright, so I went ahead and drew our triangles, and the way I figured out where to put the letters is that you should remember that the hypotenuse is always the longest side. So that means that TR had to be our hypotenuse. And then after that, it didn't really matter where you put the other two. I mean, I put the second longest side with the side that looked the longest besides the hypotenuse, so. Then we note that angle S corresponds to angle V, so I put them in the same spot. And then angle T corresponds to angle W, so I put those two in the same spot as well. What is the value of tan of W? So in SOHCAHTOA, tan is TOA, which is opposite over adjacent. So here's angle W, and you notice that we don't know the side lengths of any side actually, but we do know that angle W corresponds to angle T. And corresponding angles in similar triangles are always going to be congruent. So that means that their trigonometric ratio would also be the same. So what I'm trying to say is tangent of W would be equal to tangent of T. So let's find out what the tangent of T is. So the side opposite of T is this one right here, which is 440. And then the side adjacent to T is this side right here, which is 384. So that means our answer is 440 over 384. Now that doesn't seem to be any of our answer choices, so we will need to simplify this. And you don't even need to think about it, just put it in Desmos. And then you can click this fraction button in the blue box to the left. And you get that the simplified fraction is 55 over 48, making our answer D. Question number 8. The side lengths of right triangle RST are given. RS is equal to 20, ST is equal to 48, and TR is equal to 52. Triangle RST is similar to triangle UVW, where S corresponds to V and T corresponds to W. Okay, so this is literally the exact same problem as the question before, except the numbers are smaller. Alright, so I went ahead and drew our two triangles. Once again, I knew where to put the letters because the hypotenuse is always going to be the longest side. So here, the side with the longest length is TR, so that had to be our hypotenuse. And then as for the other two sides, it really doesn't matter where you put them. I put the side that kind of looked the second longest with the length that was the second longest, so there you go. And then in the triangle on the right, where we don't have any side measures, we know that angle S corresponds to angle V, so I put them in the same spot. And then angle T corresponds to angle W, so I put those two in the same spot as well. What is the value of tan of W? So in SOHCAHTOA, tan is TOA, which is opposite over adjacent. So here's angle W, and once again, we don't have any side lengths in this triangle at all, but we do know that angle W corresponds to angle T, which means that they'll have the same trigonometric ratio because they have the same measure. So basically, tangent of W is equal to tangent of T. So let's go ahead and find out what tangent of T is. Here's the opposite of T, and that's gonna be 20. Then here's the adjacent of T, and that's gonna be 48. So our answer is 20 over 48. But that doesn't seem to be any of our answer choices, so we will need to simplify this fraction. But you can do that by just putting it in Desmos, and then clicking the fraction in the blue box to the left. And we get that our simplified fraction is 5 over 12, making our answer B. Question number 9. In triangle RST above, which is really to the left, point W, not shown, lies on line RT. So let me just draw a random point, and we'll call this point W. What is the value of cosine of angle RSW minus the sine of angle WST? So here, to get these two angles, we're going to need to draw a line from point W to point S. And then they're asking us to find the cosine of angle RSW. So RSW, that's this angle right here, minus the sine of angle WST. So WST, that's this angle right here. Now you should notice here that the line from point W to point S intersects a 90-degree angle. So that means that no matter what, the green angle plus the pink angle will always equal 90 degrees. So there's a little shortcut that could apply here. When two angles added together equal 90 degrees, that means that the sine of one angle is equal to the cosine of the other. So here in this example, the cosine of the green angle, which I'll call angle A, would be equal to the sine of the pink angle, which I'll call angle B. That means that if we were to do the cosine of angle A minus the sine of angle B, we would end up subtracting the same number from itself. So let's say that the cosine of angle A was 2, that means that 2 would be equal to 2, so 2 minus 2 would be 0. So that means our answer would actually be 0. Question number 10. Triangle ABC is similar to triangle DEF, where A corresponds to D and C corresponds to F. Angle C and F are right angles. Alright, so here are the two similar triangles. On the left you have triangle ABC, and on the right you have triangle DEF. Let's keep reading. If tan of A is equal to square root 3, so tan in SOHCAHTOA is TOA, which is opposite over adjacent. Now while the trig ratio looks like it's not a fraction, it's really just over 1. So here's angle A. Opposite of angle A is this side right here, which is going to be square root 3. And then adjacent to angle A is this side right here, which is going to be 1. Let's keep reading. And DF is equal to 125, so that means this side is 125. What is the length of line DE? So we're trying to find the length of this hypotenuse right here. First up, let's find the hypotenuse in triangle ABC, or the triangle on the left. So we're trying to find this side right here. Now we're trying to find a missing side in a right triangle, and to do that we can just use Pythagorean theorem, which is a squared plus b squared equals c squared. So 1 squared plus the square root of 3 squared is equal to c squared. Now you could put this in desmos, but I feel like this is pretty obvious. 1 squared is 1, the square root of 3 squared is just 3, so 4 is equal to c squared, which means that c is equal to 2. So this side, the hypotenuse, is equal to 2. Now, we know that these triangles are similar, which means that their corresponding sides are proportional. So, to go from 1 to 125, they multiplied by a certain number. And I think it's obvious what that number is. They multiplied by 125. So, to find the length of this hypotenuse right here, we can just take our hypotenuse over here, which is 2, and then multiply it by 125 to get us 250. Which means our answer is D. Question number 11. Triangle ABC is similar to triangle DEF, where angle A corresponds to angle D, and angle C and F are right angles. The length of line AB is 2.9 times the length of line DE. So we can call line DE X, and we know that line AB is 2.9 times that, so 2.9x. If tan of A is equal to 21 over 20, so in SOHCAHTOA, tan is TOA, which is opposite over adjacent. So here's angle A. Opposite of angle A is this side, which is going to be 21. And then adjacent of angle A is this side, which is going to be 20. What is the value of sine of D? So in SOHCAHTOA, sine is SO, which is opposite over hypotenuse. So here's angle D, and we want to find out what the opposite side is and what the hypotenuse is. Here we have two similar triangles, and in similar triangles, corresponding sides are proportional. So what that means is that to go from this hypotenuse in the left triangle to this hypotenuse in the right triangle, they multiplied by a certain number. Or in this case, they divided by 2.9. That means that we can find this side length by taking this side length on the left side and then dividing it by 2.9. And the same would also apply to this side length on the bottom. We would just take this side length and then divide it by 2.9. So let me go ahead and put that in desmos. And we get that the length of the blue side is equal to this number right here, and the length of the green side is equal to this number right here. Alright, I went ahead and kept them as fractions because I didn't want to write all of those decimals down. So now we have a missing side length in a right triangle, And to find that side length, we can just use the Pythagorean theorem. So that's going to be a squared plus b squared is equal to c squared. Or in this case, we'll call this side a, this side b, and then this side c. Now let's put this in desmos. And what I'm going to do here actually is I'm going to set this equal to a, and then I'm going to set this equal to b. So now I can just do a squared plus b squared. And then instead of an equal sign, you want to put a tilde. And then c squared. And we get that the value of c, or x, is equal to 10. Alright, now that we finally have all the side lengths we need in triangle DEF, we can find the value of sine of d. So that's going to be this side, 21 over 2.9, over this side, 10. And that's not a pretty fraction, so we can actually put this in desmos, like this. And then click the fraction button in the blue box to the left, and we get a much prettier fraction. So our answer will be 21 over 29. Question number 12. In a right triangle, the tangent of one of the two acute angles is square root 3 over 3. So here we have an acute angle, and I'll call this angle A. And here we have another acute angle, and I'll call this angle B. So theoretically, let's say that the tangent of angle A is equal to square root 3 over 3. In SOHCAHTOA, tangent is TOA, which is opposite over adjacent. So once again, here's angle A. Opposite of angle A is this side right here, which would be square root 3. And then adjacent of angle A would be this side right here, which is 3. What is the tangent of the other acute angle? So they're asking us to find the tangent of angle B, and that would just be once again opposite over adjacent. So opposite of angle B is 3, and then adjacent of angle B is square root 3. So that means the answer is 3 over square root 3, or D. Question number 13. Triangle ABC is similar to triangle DEF, where angle A corresponds to angle D, and angle C corresponds to angle F. Angle C and F are right triangles. Alright, so I went ahead and drew our two similar triangles. If tan of A is equal to 50 over 7, so in SOHCAHTOA, tan is TOA, which is opposite over adjacent. Here's angle A. Opposite of angle A is this side, and that's going to be 50. And adjacent to angle A is this side, which is going to be 7. What is the value of tan of E? So once again, tan is opposite over adjacent. So here's angle E, and we're trying to find this side, the opposite, over the adjacent. Now we don't have any side lengths in the triangle on the right. However, we do know that angle A corresponds to angle D, angle C corresponds to angle F, and following that logic, angle B would also correspond to angle E. Now since these two are corresponding angles in similar triangles, that means that their angle measure are going to be congruent, and that their trigonometric ratio will be the same. So basically what I'm trying to say is tan of E will be equal to tan of B. So let's go ahead and find out what tan of B is. So here's angle B. Once again, tangent is opposite over adjacent. Here's the opposite, that's 7, over the adjacent, which is 50. So our answer will be 7 over 50. Question number 14. In triangle JKL, cosine of K is equal to 24 over 51. So in SOHCAHTOA, cosine is K, which is adjacent over hypotenuse. So here's angle K. Adjacent to angle K is this side right here, which is 24. And the hypotenuse is across from the right angle, so that's this side. And this will be 51. Let's keep reading. And angle J is a right angle. Already did that. What is the value of cosine of L? So here is angle L. And remember, cosine is adjacent over hypotenuse. So adjacent to angle L will be this side right here, which we don't know. So first, we need to find out what the side length is. We're trying to find the missing side length in a right triangle, which means we can use Pythagorean theorem. That's going to be a squared plus b squared equals c squared. So 24 squared plus b squared, I'm calling this side b, is equal to 51 squared. Let's go ahead and solve for b. Instead of an equal sign, you want to put a tilde. And you get that b is equal to 45. So now we can go ahead and write our ratio. Adjacent to angle out is 45. And then the hypotenuse is 51. So our answer will be 45 over 51. Okay, so I just checked the answer key, and for some reason 45 over 51 isn't one of the allowed ways you can answer that. So they say the answer is 15 over 17, and you can get this by typing 45 over 51 in desmos, and then clicking the fraction in the blue blocks to the left, and you'll get that 45 over 51 simplified is 15 over 17. So once again, it's the same fraction. I have no idea why it's not correct. Alright, that was 14 practice problems on trigonometry, and desmos is going to be useful in some of these problems where you have to use the Pythagorean theorem to find the missing side length. Now for these trigonometry problems, you don't really have to remember that much. The first thing you have to remember is SOHCAHTOA, so sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. Other than that, you should also remember that corresponding angles will be equivalent to each other, and that means that their trigonomic ratios will also be equivalent to each other. And then one last thing is that right here, whenever two angles are complementary, which means that they add up to be 90 degrees, the sine of one angle will be equal to the cosine of the other angle. Alright, pretty easy. That's gonna be it. Good luck studying, and I'll see you.